Alright, so in this video, I'm just going to go over the chapter 4 review for the test coming up. I'll break it up into parts so it doesn't feel so long. Okay, so questions 1 through 2, it says it's giving you f of x and g of x. Perform the indicated operation. So that's referring to the f plus g and the f minus g. Those are the operations. Excuse me. So for f plus g, we take the function of f, and we're going to add the function of g. Combine like terms. So I see we have 2x squared, excuse me, 2x squared and x squared. We're going to add them together to get 3x squared. Okay, we're going to get 9x and negative 3x. That's going to combine to be negative 6x. And then we have the plus 7. And there you go. That would be your answer. For the f minus g, you'll do the same thing. Take the 9x plus 2x squared, and then you're going to subtract. Now you have to subtract the whole thing, so this negative is going to have to distribute. And so we have 9x plus 2x squared minus x squared plus 3x minus 7. And we'll do the same thing. We'll combine like terms. We have positive 2x squared and negative x squared. That's going to make positive x squared. We have 9x and positive 3x. That's going to combine to be 12x. Also, going back here, that's 9x and negative 3x. That should be plus 3x right there. Plus 6x, sorry. Okay, sorry. Now going back to this one. Minus 7. Holy cow, I'm struggling. And then minus 7. Alright, so this would be equal to the f minus g. Next one, you have two different functions for f and g. You're looking to do the indicated operations of addition and division. So for multiplication and division, so we have 4x to the 2/3 times by 2x to the 1/3. The 4 and the 2 are going to have to multiply together to make 8, and then it's going to become x. Now these have to add right here, 2/3 and 1/3, so 2/3 plus 1/3, which will be 8x, because that added together is going to be equal to 3 over 3, which is going to be equal to 1. So that's going to be to the first power. For the next one, f divided by g, so that's going to be 4x to the 2/3 divided by 2x to the 1/3. We're going to divide the 4 and the 2 together because we can. That's going to make it 2. And then whenever we divide these together, all we have to do is subtract the exponents. So we're going to have 2/3 minus 1/3. 2/3 minus 1/3, because they have a common denominator, we can take and subtract the numerators. So we're going to get 2x to the 1/3. Alright, next part right here, we have new functions for f and for g, and we're looking to do f of g of x and g of f of x. So these are compositions. That's what we're trying to do. For f of g, g is on the inside, which means this is going to go into that spot right there. So 2x minus 1 squared plus 4. So again, just kind of highlight this right here went in right here, squared plus 4. And honestly, you can leave your answer just like that, and I will be happy to accept it. For the next one, we're going to do g of f of x, meaning f of x goes on the inside. So this is going to be plugged into this spot right here. So that's going to be 2 parentheses. Then we're going to input f of x squared plus 4 minus 1. Now this one requires a little bit of cleanup because this 2 can be distributed. Okay, so then that's going to make it 2x squared plus 8 minus 1. And then finally these can combine. So that's going to be 2x squared plus 7. There you go. So that's the first page down. For the next page, we are going to do the simplifying radicals and how we can do that. So these ones right here, we have a radical. It's a cube root radical, and it has both numbers and variables. So to simplify the whole thing, we're looking for things that can be cube rooted and ways that variables can be grouped into 3 if possible. So what I like to do when I first see this is take a look at the number. So first take the number and see if you can cube root that. If in your calculator, this is what you would do in your calculator. You would do 192 raised to the power of 1/3. Now, if you do this in your calculator, this is going to give you, actually, let me see 1 second. 192 raised to the 1 divided by 3. That's going to give you 5.769. I don't want this as an answer. That is not an acceptable answer. You can also see that this is multiple choice, so that's not presented there. So instead what we're going to do is we're going to find out if 192 has any factors that are cube roots. So what are cube roots though? So that's what I like to do. So cube roots. So I know 2 cubed is equal to 8. So I know 8 is a perfect cube root. Okay? 4 to the power of 3 would be equal to 64. So I know that that one is a perfect cubed. And then 5 to the power of 3 would be 125. So that's also a perfect cubed. Now, I'm not going to bother going anything further than this. Honestly, this won't work either because this is not going to be a factor of 192 since it's more than half. So let's see if 64 can divide into 192. So 192 divided by 64, 192 divided by 64 is equal to 3. Perfect. That's awesome. So then what we're going to do is bring this down here, and we're going to rewrite this as 64 times by 3, because 64 times 3 is 182. Then we have u to the 7th times by v. Okay. Now we're going to try and simplify. I want to try and take anything out. I can only take something out if it's a perfect cubed and if it can go evenly into these numbers right here. So starting with this right here, I now know 64. We can look right here. The cube root of 64 is 4. That's how we got it. So this can come out as 4. So this is going to come out as 4. Okay, now the 3 cannot come out. This is going to stay because I can't take the cube root of 3. And there are no factors of 3 that you can take the cube root of other than 1. Now for the variables, so let's look at u to the 7th. For variables, what you're going to do is you're going to see how many times 3 can go into its exponent. 3 can go into 7 twice and 1 left over, which means this can come out as u squared, but left behind is going to be u. Okay, so again, 3 can go into 7 twice, which is why we have it squared right here. But there's 1 left over, so 1 has to stay. As for the v, this is to the first power. 3 cannot go into 1, and so therefore this has to stay. So our final form, we have 4u squared on the outside. Then we're going to have the cube root. What had to stay in? The 3 had to stay in. One of the u's had to stay in, and v had to stay in. This would be the final answer, giving us C as our answer. Okay, so let's try that again. Excuse me. Let's try that again with this one, although this is a 4th root. So again, we have numbers here. I'm going to generate a list of 4th roots. So for 4th roots, 2 to the 4th. 2 to the 4th is going to be 16. Now 3 to the 4th is going to be a large number. 3 to the 4th power is going to be 81. I already know that this is not going to work because 81 is greater than 48, therefore it's not a factor. So let's see if 16 is a factor. So 48 divided by 16. 48 divided by 16 is going to be equal to 3. So here we go. We're doing the 4th root, 16 times by 3, x to the 8th, and y squared. Same process here. Can I take the 4th root? I can break 48 into 16 times 3. Those are the same. Now I see if I can take the 4th root of this. 4th root of 16. Yes, I can. I already know that because of this part right here. The 4th root of 16 is 2. So therefore, I can bring this out as 2. This is going to stay. Now let's check the variables. 4 can go into 8 twice with none left over, which means this can come out as x squared, and this is going to be eliminated because 4 goes into 8 without any left over, so that's gone. Okay, now 4 cannot go into 2, therefore this is going to stay, nothing can come out. So I have 2x squared on the outside. On the inside, I'm going to have 3y squared. Okay, so 2x squared, 3, yep, that's going to be A as our answer. Okay, for 9, first thing that I'm going to do is I'm looking to combine like radicals. This is a like radical. Whenever they have the same radical, so square root, fourth root, third root, and same radicand, all I'm going to do is combine these right here. So I have 2 square root of 18, and that's going to become negative 3 and positive 6, which is going to be negative 3 square root of 3. Okay, now this answer is not in any of these right here, so I'm going to see if I can simplify this. So 18. So let's do the same thing that we did up here. We're looking for perfect squares. So squares, square roots. So perfect square roots would be 2 squared, which would be equal to 4. 3 squared would be equal to 9. And right there you can stop because 9 is a factor of 18. So this is going to become 2 square root of 9 times by 2, because 9 times by 2 is 18. And then see what you can take the square root of. I know I can take the square root of 9 to get 3. So this can come out as 3. So I'm going to have 6 square root of 2 minus 3 square root of 3. Also, just realizing this should be plus, 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 because 6 negative 3 is positive. So the answer should be D. For 10, simplifying this expression right here, it just requires us to FOIL. You can see that these are binomials, they're being multiplied, so we are going to FOIL. So multiply those together, multiply those together. So not too bad. There's a little bit of, it's a little tricky when you get to the radicals, but let's go through this. So 4 times 2 is 8. So I have 8. 4 times the square root of 5, I'm just going to leave that as 4 times the square root of 5 because I can't multiply the 4 inside there because this is a radical and that's not. These two, when I multiply these together, again, I can't multiply the 2 into 5, but I can multiply it into 3, so that's going to become 6 square root of 5. Then I'm going to multiply these together. So when I multiply those together, I'm going to have 3. Now I can multiply the square roots of 5 by square root of 5. Square root of 5 times the square root of 5 is going to be square root of 25. And this right here is 3 times 5, and that's equal to 15. Okay, so I have 8 plus, these can combine to become 10 square root of 5. So 10 square root of 5 plus those. And then these can combine. 8 and 15 can combine to be 23, then plus 10 square root of 5. So the answer is right there. Alright, for this one, I'm going to try and see what I can simplify from the radicals, and then we'll go from there. So I see the square root of 16. Okay, so I know the square root of 16 is 4, so that's 4. Now I still have to leave the square root of cube root right there, square root of x cubed. I know that square root of 25 is 5. Okay, now I can multiply these numbers together. So 2, 4, 5. So 2 times 4 times 5 is 40. Okay, now I'm going to multiply these together because they are both under square roots, so that's going to be the square root of x to the 4th. And then I do the same thing as I've been doing all along. This is a square root, by the way. How many times does 2 go into 4? Twice with none left over. So 40x squared. Okay, we'll do something similar here. See what you can do with these square roots. I can't take the square root of 32, but let's see if I can, if 32 has any perfect square. So square roots, so we have 2 squared, that's 4, 3 squared, that's 9, 4 squared, that's 16, and I'm going to stop there because 16 divides into 32 twice. Okay, so I have the square root. I'm going to do 16 times 2x divided by 9x to the 4th. Okay, let's see what we can bring out. So square root of 16, I know I can bring out a 4. So I'm going to bring out 4, but I can't do anything with that right there, so that's going to stay as square root of 2x. Okay, on the bottom, can I bring anything out? The square root of 9, that's 3, so I can bring that out. And then the square root of x to the 4th. Well, this is squared. 2 goes into 4 twice with none left over. So then that's going to become x squared. So the only place I can see a radical is here, because that's the only thing that could not come out. And there you go. Okay, we're going to call that the first part of this video, and I'll upload another one for pages 2 and 3.